Hello.
Hello?
Okay. Can you? Okay. If I'll call out the names. I'll call out the names, and only that person will speak. Others will not speak. Okay. Starting with Angel Mary Thomas. Hello, Angel. How are
Hello?
you? Hello. Can you
I'm
hear me?
fine.
Okay. Angel.
Yeah, I can.
Angel.
Hello?
Yeah. Can you share your email ID so that I can share no the some homework after the session? Just
Okay.
type your email ID, Angel. So all of
Yes.
yeah, just type in the chat, the messaging window that the chat window is there. You can type your name.
Sorry, sir?
Can you type your email ID? I need all of your email IDs because after the session I'm going to share with you some assignment for as a homework. So I need no Angel. Can you type your email in the messaging window? Just type your email ID.
Yes. Sorry, did you listen?
I'm just seeing that the message has come. Yeah, I've got it. Okay, Angel. All of you are from in class 10, right? Correct, Angel?
Hello? Yeah?
All of you are in class 10. Am I right?
Yes, sir.
Okay, so you have just got promoted to class 10, or right? All of you have got promoted to class 10 now, or you are already? Uh, am I
No,
right?
we are promoted to class 10.
Promoted to class.
Yes.
Good.
Hello?
Yeah, I can hear
We are
you.
promoted to
Okay,
we are
fine.
promoted to class 10.
Sure. Okay, can I now,
Sure.
Angel, can you just mute yourself? And can I call out
Yes.
Chinmay? Chinmay, can you say hello?
Yes, sir.
Okay. Angel, Angel, you can you can mute. Yes. Chinmay, how are you? Good morning.
Fine.
Yes, Chinmay. Chinmay, can you share your email ID with me? Can you just type your email ID with me?
Yes.
All of you, can you just type your email ID with me one by one?
Done.
Okay, done. Good. Fine. Darshan, Chinmay, you can just mute yourself, and I would like to speak to Darshan. Darshan, good morning. Darshan, go on.
Darshan. Sleep, sleep, sleep.
Can you hear me, Darshan? Hello, Darshan. Is Darshan able to hear me?
Hello, sir.
Yeah. Is Darshan there? Okay.
There's some problem, so we cannot hear you.
Okay, fine. Angel, can you mute yourself? So, Deepika, can you speak? Deepika, hi, good
Yeah.
morning. Hi, Deepika, how are you?
Good morning.
Good morning, very good
Fine.
morning. So, Deepika, can
Good
you
morning.
share? Can you type your mail ID in the messaging window?
Yeah, I'll send it. Yes, please.
Okay, got it.
I'll send it.
Okay, fine, Deepika.
I'll
Fine.
send it to you.
Yeah, thank you. Thank you, Deepika. So then
Thank
after that, Jivita. Oh, Darshan is not able to hear me. Darshan, you need to check your no audio system.
you. With you. Speaking with you.
Darshan, you need to check your audio system. Darshan, Darshan, please. Okay, Deepika. Hello, Deepika. Hello, Deepika. Can you hear me? Can I have your all of? Can I have your attention, please? Jivita, can I request your attention here? All of you, please. Okay, Darshan. Darshan, you can. Deepika. Hello. Can you all hear me?
Yeah.
Hello.
Yeah, we can hear you.
Okay. Kirti, okay. Hi, Kirti. I was actually calling out for Deepika. Kirti, Can you share your email ID, please? Good morning, Kirti.
Yes, sir. Yes, sir.
Just share your.
Should I give my father or?
The mail ID that where you can access the homework that I'm going to give you. Okay. Okay.
Yeah.
Okay. Then Jivita. Jivita, can you share your mail ID, please? Jivita.
Yes, sure.
Deepika, Deepika also Deepika already shared your mail ID. Yes. Jivita, you need to share, and Kirti. Kirti, can I have your mail ID, please?
Yeah.
I got your mail ID. Yes, Kirti. Thank you. Okay. Jivika, is Jivita there? Is Jivita? I'm sorry. Jivita, are you there? Jivita, are you there? Okay, Jivita. Jivita, can you share your mail ID, Jivita?
I have done, sir.
Okay, you've done it. Thank you, Jivita. Good. Darshan, can you hear us? Darshan, able to hear us? Okay, I think Hashmita has joined right now. Hashmita, can you hear us, Hashmita? Hashmita, you need to unmute yourself, Hashmita, to speak. Hashmita, can you hear me?
Yeah, I think yeah.
Okay. Can I have your mail ID?
Yes. Uh,
Yes, Hashmita.
yes.
Is anyone who is not able to hear me? Just raise your hand. Say that you are not able to hear me. Darshan, your audio issue has been resolved. Darshan. Okay, Hashmita, I got your mail ID. Okay, Hashmita. Okay, we can hear. Thank you. Fine. Okay, Darshan. Okay, let's start. Okay, I have one request to all of you. All of you, please unmute. No, mute yourself. Can you mute yourself? You can't. Okay, Darshan. Okay, nothing to worry. Okay. All of you, please unmute yourself. Mute yourself. I'm sorry. Mute yourself. All of you, please mute yourself. Okay, done, sir. So all of you, Hashmita, can you mute yourself? Darshan, you can't hear us. Done, sir. Okay. Angel is done. Darshan. Yes, sir. Darshan. Okay, Darshan. Fine. Darshan, I am unmuting yourself. You. Okay. Then Jivita, can you mute yourself? Okay, good. Fine. Done. Okay, good morning to you all. So my name is Shantanu. I mean, all of you who don't know me, my name is Shantanu, and I'm going to teach you today and tomorrow about simple machines. So the session is of 1 hour each today. Today 1 hour and tomorrow same 10:30 to 11:30 1 hour. So we are going to cover the machines, and whoever has any question, just stop me, unmute yourself, and ask me if I didn't understand. So I will explain that again and try to make you understand. So the topic is known to you. So there are certain guidelines to it. I may ask, I will ask in the process of the session, during the session, I may ask some questions. And whoever knows the answer, please unmute yourself and speak out the answer. You have also have an option to answer it through chat. So anyway, I need your complete 100% participation and also attention. And this session is getting recorded. So you'll be able to access this recording after the session. Okay. So now and whatever we discuss, whatever you do in the session, everything is recorded right from the time you have joined the session today. Okay, good. So the topic is simple machine. So can anyone tell me what you understand by machine? Yeah, I have given you some picture on the board. That there is different types of machines are there. Can I speak louder? Yes, I can speak louder. Am I audible, Kirti, now? Kirti, am I audible? Better? Yes, good. Okay. So all of you, so what do you understand by machine? What is machine? Anybody can you answer? Just simple. I have given you the some of the examples there. What is machine? You can type your message also, not an issue. I just want to know what is machine according to you. Yes, that makes our work easy. Yes, day in, day out, we use a lot of machines. Even, even some of the body parts are also used as a machine. Our hand, our leg, our head, we'll see that what are the different types of machines. So these are all examples of simple machines. We'll see that there's the levers on the right on this side. The levers are there. The inclined plane. There is pulley. There is a wedge, screw, wheel axle. All are machines. So then, what is the definition of machine? Are you going to? The question is, are you going to study all of this? No, we are not going to study all of this. We are going to study in details the lever. We are going to study in details the pulley. Okay, we may study some part of inclined plane also, and one more which is not there. These three mostly will be studying lever and pulley, some understanding about inclined plane and some gear. So today's sessions I will try to cover the lever part, and tomorrow we'll cover pulley. So in the session we'll go each and every topic, and I assume that all of you are following the Selena publication. Am I right? All of you are following Selena concise publication. Is that right? Yes, very good. So you will be able to relate what I speak once you open the book later. Now my question is, what is force? So to do our work, we have to apply force. What is force? Anybody? What is force? Yes, what is force? Anybody, what is force? You have already studied force, right? Force is a strength. Deepika says it's a strength. Okay, can you elaborate what is force? Little bit more. Force is something, an effort that we apply to do work. Am I right? Are you getting me? The force is an effort to apply, to do some work. Yes, good. So in other words, push. Yes, it's an effort. If you have, if you remember the force that you learned in the class 9, yes, it's effort by us. Hashmita says it right. The definition of the force that you when you studied the Newton's laws of motion in the last year, you must have seen that force is what? It's a push or pull, which changes the motion of an object. It can move the object, it can stop the object, it can change or increase the speed, decrease the speed, it can change the shape, it can change the direction. We'll see using these machines, we'll see that how the force play the role. What kind of how the force, what does force do while using this machine? How do they do work? How the force is applied? All we are going to study in this particular chapter. So it's basically an application of input force to do some work. Now, coming back to this, what is simple machine? A basic definition. Your book has also the definition. If I want to elaborate the definition, it's a device. All of you said to make work easier, but how? A simple machine makes work easier by one of these following functions. Can you tell me what is this machine? What is this machine? Anybody, what is this machine? Tell me what each one of these, the number one, what is the machine? So I am marking this all by number. Number two, what is the machine? Number three is the machine, and number four is the machine. What are the machine? What is the machine? Have you ever come across this? What is it doing? Anybody? Angel, what is this machine one? It's a wheel and gear. Which one is the two is a wheel and gear, Kirti said. Yes. So first one is a hydraulic jack. You see the car, it the simple machine, with the use of this machine, we are able to lift a very heavy car. Even a lorry can be lifted by this jack. Such a simple small machine. So that means what? With the little application of the effort, we are able to do a larger work. And that is why, yes, all of you are right. And that is why it is called force multiplier. Yes, all of you are right. I'm seeing all these, answers from you guys. Now, this hydraulic jack is a force multiplier. With the amount of little force, it can lift a heavy object like car or a lorry. Right? Are you getting me? So that's what is called the force multiplier. Now, coming back to the machine 2, you see that what are you doing? It's a very typical example of wheel and axle. I think Deepika has said. So what you do? You see in the cycle. This is used in a cycle, right? It is used in a cycle. What you do in the cycle? You pedal on the larger wheel or the larger, it's basically a gear, larger tooth gear, and the cycle moves. So you are changing the point of application effort. You apply the force here, and cycle moves through this rear gear or rear wheel. What is this pulley? What are you doing? You are lifting an object upward by applying a force downward. So it's a change the direction of effort. Is it not? Right? Yes, I could see all of you saying yes. Now what is this? This is the fourth one. Nobody has given an answer. What is this? What kind of machine is it? The fourth one is what kind of machine? Force by hand. Very good answer. It's a racket, right? It's a tennis racket. Now what is happening? The player hits the ball and the ball moves faster. So the gaining in speed, right? So the speed of the ball is moving at a very fast pace. So with the application of little bit of effort on the wrist, by the wrist, you are able to increase the speed. Yes, by hand or by the wrist, you are increasing the speed of the ball. So if I want to summarize, what are the different types of functions the simple machines does? It reduces the effort by changing the point of application of effort to a convenient point, by changing the direction of the effort, or by producing a gain in speed. So it can do any of this. Now you can ask, can it do two jobs simultaneously? In some clevers, yes. In some clever it cannot be. But understand, the point number 1 and number 4 cannot be done simultaneously by the same machine. You need two different machines to increase the force in one case or to increase the gain in speed. It is either or. You cannot increase both the speed as well as the force from the same machine. So is it clear for you what I have discussed about the force? What are the simple machines? Is this understandable? Anybody who has not understood these applications? Good. Now to understand machine further, yes, completely clear, very good. To understand machine further, we need to understand certain terms. We have studied force. Now let's see that what are those terms. The terms is called effort. We all discussed about the effort, the force that we apply on a machine. At last, what I said I didn't understand. Okay, I said to understand the machines, we need to learn certain terms, right? The terms.
No, sir. Like you told that.
Yeah, Kitty, tell me.
You just told that you cannot use simultaneously the first one and the fourth one. So.
No, said that I could not get you. Can you be closer to your mic and speak? Are you using a speaker or a headphone?
The headphone.
Okay. Can you repeat it, Kirti? Yeah, now it's better. Everybody else,
Yeah,
can you? Yeah, go ahead. I can hear you now, please.
Yes, sir. As you told that the first diagram and the fourth diagram, both the
Okay.
is driving
So
the
yes,
machine.
I said a machine cannot be used for both to do the function 1 and function 2. It can be used either to increase the force, that is output will be more than the input applied force, or it can be used to gaining speed, right? Both cannot be possible from the same machine. So a machine cannot work, in other words, a machine cannot work both as force multiplier or speed multiplier. Is that clear?
Yes, sir.
You'll see that mathematically you'll see that why I'm saying so. I'll come back to it very soon to explain further. Because to do that, yes, anybody has asked any question? No.
Music.
Okay, fine. Jivita, are you using two machines? Two systems? No. No? Okay, fine. No problem. It shows two names against you, two entries against you. That's the reason I'm asking. Okay, fair enough. Now to understand these machines further, we need to understand certain terms to all of you. Effort you already know, the force that we apply, and the load is something that we have to want to overcome, right? By overcoming the load, we do the work. So if you see the simple example, this is a, what is this? This is a lever. Using the lever, you are able to push this object on the ground. So load is, this object is the load and effort is what you are applying. Now this leads to a term, new term to be new term to be defined. That's called mechanical advantage. A mechanical advantage is defined as the load upon effort. Now to Kirti. Kirti, can you hear me? Yes?
Yes.
So if mechanical advantage is defined as load upon effort, what is this? What would be its unit?
Excuse me, sir.
Okay, what could be the unit of mechanical advantage? It is defined as load upon effort. What is load? Is again a force. What is effort is also a force. Darshan, you can't hear me. I think everybody else is able to hear me, Darshan. You just need to check your audio, Darshan. Am I not audible to everybody else? Am I audible to all of you? Except for the, yes, you are. See, Darshan, you need to check your audio. Okay. So others are able to hear me. So I don't see any issues at my end, Darshan. So you just need to check the audio at your end, Darshan. Okay. So Kirti, question to you, Kirti. Mechanical advantage is defined as load upon effort. So what would be its unit? Hello, Kirti, are you there? Kirti,
Yes.
you can unmute yourself. See what I have said.
Yes, yes.
Just try to understand. Load is also a resistive force. Effort is also force you apply. So load upon effort. So force upon force. What would be its unit? Anybody? What would be its unit? What could be the unit of mechanical advantage? What is the unit of force?
Newton.
Newton. So I have a Newton in the numerator. I have a Newton in the denominator. So what would be the unit of mechanical advantage? The unit.
No unit.
No unit. Yes.
Unit.
No unit. Units will get cancelled. No unit. Okay, I can repeat. I asked that question. I think some of you said it is no unit. Am I right? Who is that? Who is that? Okay. I think two or three people. Okay, two or three people spoke together, so I could not get who is that. Okay, Angel. So mechanical advantage. Can you explain? I'll do it again, Deepika. No issues. I'll just remove whatever I have done already.
Yes.
So Deepika, can you hear me? Can you unmute yourself? Okay, one of you, not all of you, one of you. Now, what is load, Deepika? It's an opposing force. This is we are trying to move this weight. Weight is what? Weight is a force, right, Deepika? Right, weight. Weight is a force. What is weight, Deepika?
It's a light force.
It's a force. It's a force by which the earth pulls the object towards it. Correct, no? So, what is effort? Effort is also a force. You are applying a force to lift this object. Correct, no? Right?
Yeah.
So load is I can say load mechanical advantage is defined as ratio of load to effort. So load is also a force, effort is also a force, and we know the unit of force is Newton. Unit of force is Newton. Now Newton upon Newton will get cancel each other. Am I right? Right? No. So it will have no unit. It's a ratio of two forces. Yes. Angel, did you get it? Angel, did you get it? Why mechanical advantage will not have it will not have any unit? Deepika,
Yes, sir.
Deepika, did you get it now?
Yeah, yeah.
Okay. So it's a ratio of two forces. So the unit will get cancelled each other, right? Okay, good. So this is one term. Now, tell me what could be the value of mechanical advantage? So it can have equals to 1, it can be less than 1, and it can be greater than 1, right? What does it mean if it is equals to 1, Deepika? What is the meaning if it is equals to 1? Does it not mean load equals to effort? Correct? Right? So load equals to effort means you are applying the effort and the overcoming force also is the same. Right? Correct? Now what is this? Yes. So here load is greater than effort.
Yeah.
So load, you mean you are overcoming the effort, overcoming a larger load than effort, right? Now, sorry, here it will be less than over. I'm sorry, this is not the case. Let me correct it. It would be here. Load is more than effort, right? Here it is load is less than effort. What does it mean? It means you are applying more effort, but the load that you are overcoming is very less. Correct, no? Right?
Yeah.
Now,
Yeah.
let's go back to our examples. Yes. See, we have discussed about these examples. We see that where the what is the mechanical advantage in each of these cases. Let's look into that. So you see here in the hydraulic jack, you are lifting a larger load by the application of a smaller effort. So mechanical advantage is greater than 1 here. All of you agree? Is it not? Deepika, yes. Good. Now what are you doing in this case of pulley? Whatever effort you are applying, you are lifting the same load. Only the direction has changed. So here it is load equals to effort. Right? Correct? Yes. Now here, what is it? The load is a small ball. This is your load, a small ball. What is effort? Effort is your a racket. You are applying the effort with your racket. Now the load is very small. Correct? No? Here if you see, load is smaller than the effort. As a result of that, what is happening? It is gains in speed. All of you get it now? It gains in speed. So when the load is less than effort, it is a speed multiplier. What is this? This is a force multiplier. And what is this? This is the change in direction of the, this is just change in direction. Do you get this? All of you, did you get this? So what does it mean? Yes. Now I summarize. What does it mean? If MA mechanical advantage is 1, is the change in direction of the force. Remember this. If mechanical advantage is less than 1, it is basically gaining speed. If it is greater than 1, this is called force multiplier. Have all of you
Excuse
got
me,
this?
sir.
This is one of, yes. Who is this?
How does it gain speed?
Gaining in speed? Is it, who is this? This is, I think,
Sir, how does it gain speed?
yeah. Look into this. If you hit a ball, ball is very small, the weight of the ball is very less, correct, no? When you're applying an
Yes, sir.
effort, the ball moves faster or not, right?
Yes.
So you're applying a force, effort is more, but the load is less. So with the racket, the ball moves very fast, so gaining speed, right? How much is the what is the speed of racket? It is very less. Whereas the speed of the ball is more. It is moving very fast. Are you getting me?
Yes, sir.
So now you got what is the
Sir,
gaining speed? Yeah.
sir, yes. So, but this bracket also changes the direction of the ball.
Racket, no, direction of the ball. No, but you are just hitting the ball. No, take the ball and then hit. You see that how the tennis player plays. Take the ball and just hit it.
But
You're
it changes the direction.
It changes the direction when somebody else is hitting at you and you are moving it back. No. Suppose you have a ball here and you are hitting with a racket. What will happen? It will go in the same direction, right? It's only one direction. It doesn't change. It changes the direction when another player is hitting the ball at you and hitting the ball back.
Even he can hit forcefully, right?
Sorry?
Yeah.
Is it clear?
Yes, sir.
So it is. Oh, I think you are thinking of somebody is hitting the ball at you and you are just hitting the ball back. Yeah, you are hitting the ball back. That is changing direction. But I am not talking about that. You just lift a ball and then hit it at somebody. It goes in one direction, right? And the speed of the ball is much more than the speed of the racket. Okay, good. So remember this. This is one of the important inference of this chapter. We'll come back to this. We'll see mechanical advantage for each of the lever, each of the machines that we're going to study. So understand this, what these fundamentals of this. Okay, good. Now another term is called velocity ratio. So this is another velocity ratio. Velocity ratio, how is defined? Velocity ratio is defined as velocity of effort by velocity of load. Meaning distance, what is the velocity? Velocity is distance upon time. So velocity of the effort is distance moved by the effort in time t. What is the velocity of the load? Is again distance moved by the load upon time t. Now the time is same for both the effort and load. It is happening at the same time, right? So if you substitute in this formula velocity ratio, you get the distance is dE upon t by dl upon t. Finally, you are getting velocity ratio is the distance moved by the effort by distance moved by the load. So if I summarize what I said, it means this is the one. So I can say velocity ratio is also defined as displacement or the distance moved by the effort or displacement of load. So in other words, we'll be mostly using this relationship in our chapter. Velocity ratio is displacement of effort by displacement of load. Got it, everybody? So another term we found out is velocity ratio is dE, that is displacement of effort by displacement of load. Okay, so this is another, and whereas what is mechanical advantage is what mentioning here. Mechanical advantage is MAN L by E. So these are the two fundamental stuffs we are going to use in the entire chapter. So please let me know anybody has any doubt in understanding any of these two. Sorry? Anybody has any doubt in this, please let me know, because without knowing this completely, the subsequent things will not be clear to you. Okay, fine. Stop me.
Excuse me, excuse me, sir.
Yeah, please. Can you explain it again? Kirti, is it Kirti?
Sir, can you explain again?
Which one? Velocity ratio or mechanical advantage?
The velocity rule.
Okay. So like mechanical advantage, so let me remove what I've written here. So I'll come back and make a summary again later. So velocity ratio is defined as velocity of the effort by velocity of the load. Simple. This is the definition. Now, what is the velocity? Velocity is, yeah, Deepika, I'm doing it. So velocity, did you understand the definition of the velocity? This is a definition.
Yes.
Okay. Now we are going to derive the subsequent parts. Now, what is velocity? Velocity is what? Distance upon time, or displacement upon distance, or displacement upon time. Correct? No? Right?
Yes, yes.
Right. So I'm just writing both. Now, so velocity to the effort means what? Distance moved by the effort by time. Similarly, velocity of load is what? Distance moved by load by time. We just use the definition of velocity that we know. Now, time is same for both, because both the changes are happening at the same time. The longer you apply the effort, the same time the load will also move. So the time for both is same. So T is same for both. Right? Anybody has any doubt here? Now after that, what we have done, we have substituted this information into this formula. Deepika, did you understand what I am doing so far? So we substitute the definition of the velocity in the in the velocity ratio definition, and we get d upon t, and tt gets cancelled. So you are left with d upon dt, dl. Sorry, d upon dl. So it is in larger is d upon dl, because t is same, t gets cancelled. Have you got this? If you have got this, then the summary you will be able to understand. Anybody who have not understood how from velocity ratio I am getting the distance of effort by distance of displacement by load, distance of displacement by load. Is it clear so far? So if that is clear, this is just wording of this. Yeah, Asmita, I know. Deepika, Kirti, is it clear to you?
Yes.
Okay. So now what I am saying, velocity ratio, what you have developed, velocity ratio is dE by dl. This is one relationship, and mechanical advantage is L upon E. This is another relationship. Okay. Good. Fine. So we have now, yes, we have another term. So what we have done so far, we have defined two terms. I'm just keeping all these things at our in our fingertips. We have defined mechanical advantage, defined velocity ratio. Now another is the efficiency. All of you knows it. Output by input is the efficiency. You take the percentage, multiply percentage. Simple. Efficiency is work output by work input. Good. In short, it is written as W out by W in. Now,
Also the
sorry, anybody who has not understood this? The efficiency is defined as work out by work inputs. Input work done. Who does this work? Is the effort does this work? And who? What is this work done on? Work done on load, right? You apply effort, on the load and you apply your work input and gets the work done by the load. Right? No? Okay. Now all of you know work and energy are, you know work energy theorem? All of you, do you know work energy theorem? Work energy? No. Kirti doesn't know. Who knows? You know work whenever you do, nobody knows. Okay. What is energy, Deepika? Deepika, can you be there and tell me? Unmute yourself. What is energy? Energy is the ability to do the work, right? No? Deepika, can you hear me? Deepika, Kirti. If I say energy is the ability to
Yes.
do the work. Now
Yes.
when you do work, your energy reduces, right? Correct, no? So
Yeah.
work done is equals to change in energy. See, morning when you get up in the morning, you are full of energy. Now, suppose you have got up at 6 o'clock. Now it is 11:15. You have done a lot of work, so your energy has reduced, right? So whatever
Yes.
you have done the work, that equals to the change in your energy, and this is basically the energy theorem. So work done equals to change in energy. Okay. So now, have you understood at least this much? You have understood work done, how work is related to energy? Yes. Okay. Good.
Yes, sir.
Good. Good. Now let's talk about work input. Very simple. Work done by the effort is work input. Work done on the load is work output. There's no doubt about it. We just did it now. Okay. Now, since work and energy is related, so we talk about energy also. So here, if you have the energy, you can do the input work. So effort is done the by us, by the machine, or by us we apply the effort, and that depends upon our input energy. Whatever energy we have, only we can spend only that much energy, and that is the called as input energy or the effort and displacement. You know, all of you know work equals to F into S. You know this, right?
We don't know, sir.
You have not studied work energy yet, not yet.
No.
Okay, so
Oh, we didn't study it.
yes, yes. Who is that? Anybody, anybody who knows this? If all of you don't know, then I'll just spend a couple of minutes to explain this. Anybody who knows this? Okay. So what you do whenever, suppose let me give a simple example. So you apply say 2 Newton force, and the object displaces the object comes here, say 2 meter. So when you push an object, say push a table, and the table moved from A to B, so you have done some work, correct? No? And the work done is measured by applied force into the displacement of the load. So what is the load? Load is this object, correct? No? This is your load. Are you getting me? Yes. So work done on this object is the
Yes, sir.
applied force, which is 2 Newton plus multiplied by S is the displacement. So there is a separate chapter for work energy power. So I hope I'm not going to discuss further beyond this because then we'll lose our focus. So work is force into displacement. Now you know work equals to, so you whatever energy you have, that much work only you can do. So I can say that input energy. So that the energy that you supply or the work that you do can be defined as effort and displacement of the effort. This is the displacement of the effort. Correct? No? Similarly, so S is displacement, right? Yes, you are right. S is displacement. You have already studied that in the last year, right? S is displacement. F is force. These are all the known variables, right? W is work. Okay, fine. So input energy is the effort and displacement of the effort. Similarly, output energy is also different, load and displacement. So in both the cases, you see that in this example, the load also has moved 2 meter. Effort has also, because you pushed the table from A to B. The effort has moved from A to B. So both load and effort has moved the same distance in this example. So output energy, that means the load is load into displacement of the application of the load. So this is another definition. What I say, energy in equals to effort into displacement of effort. Energy out equals to what? Load into displacement of load. Anybody who does not understand this? Have you understood? Have all of you understood this? Can you just message me saying that you have understood? You
Can
want
you
me to?
explain, sir?
I can explain once again. Definitely. Okay. Fine. Who is this? This is Kirti. Okay. So work done is the force applied. Who said you have no? Is it?
It reduces your work. It
No.
reduces your work.
Reduces what? I am not able to hear you. Can somebody reduce what?
Yes, sir. What?
Get your
Sir?
Yeah. Who is this?
Kirti.
Kirti. Okay, Kirti. Kirti, okay. Can you unmute yourself? I just want to understand what exactly you understand. So let me explain this to you, Kirti. So you know work
Sir, you're
done.
not clear.
My clear means my voice is not clear.
Yes, sir.
Am I not audible, Kirti? Am I audible to all of you? Who is not able to hear me?
Yes, sir, we can hear.
Yeah, Kirti.
Even
Okay.
sir.
Okay, Kirti, fine. Oh, good. So work done is okay, fine, very good. Thank you all. So work done is apply the force applied and the displacement of the force. So you as a person, you apply a force of 2 Newton to push the object, say this is a box, this is the box, to push the box from A to B. So how much work you have done? You must have applied some effort, right? If you applied the effort, how much work you have done? The work done by you is F into S, force applied by the displacement that the force has traveled. Right? No? That is what, suppose, yeah, if I ask anyone, Kirti, if I ask you, okay, take this box and then push it from one class to another class, you have to do some work. And how much work you do? The force that you applied and how long you have traveled with the box. Right, Kirti?
Yes, sir.
And that product of that, those two, force and the distance that you travel, is the measure of work. Now input energy in our current context, when you run a machine needs a supply, right? You suppose it's an electric machine, you provide energy to the machine and the machine starts rotating. For example, the fan, you switch on the switch, you switch on and the fan starts moving. So you're providing some input energy. The input energy, how is it defined? It is the input energy is the by the effort, output is by the load on the load, correct? No, we have just found out in the previously. Output is on the work done on the load. Input is the work done by the effort. So one is by the effort means is the work input, on the load is means work output. Is it clear? So now what is the, since work and energy both are related, right? You can work as much energy you have. You cannot work more than the energy that you have. Correct? Can you do? Can you work more than the energy that you have? Kirti? Can you
No,
work?
sir.
You can't. So work and energy, that's it, is related. You need energy to do work. You spend energy to do work. When you do some work, your energy changes. Right? That's what is that work and energy are both are related. And in fact, both have got the same unit, joules. Right? So input energy is by effort and displacement of the effort. So that I have written as effort multiplied by displacement of the effort. Output energy is load and the displacement of the load. Are you getting me? Is it clear
Yes, sir.
now?
Yeah.
So because
Yes, sir.
for me, both are actually a force. Both E and L are basically a force. They are actually the force. We are differentiating by with a different letter because one is at input, one is output, but both are essentially the force. Am I right? We see that the mechanical advantage. When you learn mechanical advantage, you see we have seen that load and effort both are actually force. That's why it doesn't have a unit. Is it clear?
Yes, sir.
Anybody? See, this is again a fundamental.
Sir, then input energy is force we apply and output.
Yes, output on the load. That's what it happens. Output on the load. What is what is load? We've done in the first this slide. What is load? Is the opposing force that you're overcoming by the application of force effort. So you give the example. No, load means what you're overcoming. So that is also a force. The weight in this case, and you're applying the force. That is your effort. So both are actually the force. So the input energy is that the man needs to have. Output energy is the load to be overcome. Is it not?
Yes, yes, sir.
So input energy is force into distance. So E into effort, distance of effort. That is dE. That is what we have given the variable for distance of effort. Output energy is load into dL. That is precisely I have done here. Correct? No? So both essentially is following the same formula. Is it not? Do you all agree with me? E energy,
Yes,
E
yes.
energy out, load and DL is nothing but the same. We are just indicating that something as input, something as output. That's all. Is it clear? Okay, great,
Yes, sir. Yeah.
fine. So you just have 5 minutes. I'll just okay. Now take care of the ideal machine and real machine. Anybody has any idea about what is ideal machine? Can a machine?
No, we don't know.
Okay, fine, good. Can a machine do more work than the input? We have just now found out that you as a machine, you can only maximum work that you can do is whatever strength that you have. Can you do more work than your strength? No, right?
No, sir, your voice is echoing.
My voice is echoing. I don't. Is it for everybody? Is my voice echoing for everybody? Yes, or only for Angel?
For me, it's echoing, sir.
For you, now then you probably need to check your probe somewhere because I didn't do any changes. I've been speaking the same pace from the beginning itself. So just check
Okay, sir. Okay,
check
sir,
it.
we'll check it on.
Yeah, just check it on you anywhere because I
We'll
can't.
check
Okay, fine.
it on.
Okay, ideal. See, now tell me one thing. Say I'm taking the example of Kirti. Kirti, can you hear me?
Yes.
Kirti, suppose you whatever food that you eat, all increases your energy, right? Now
Yes,
suppose
sir.
every day you are eating say equal amount of food. Can you do work every day the same amount of work every day? Can you do?
No, it depends upon like a diet,
No,
nutrition.
suppose I say, Kirti, you take same amount of food every day. We get the energy from the food, right, Kirti? Right?
Yes, sir.
Now, can you do same amount of work every day?
Yes, sir.
Possible? Not possible. No, because
It is
no,
because
because
we
for
taking the
example,
same amount.
no, no, I'll give you the some other. Now, so for example, now it is very hot. If the temperature is very high, can you do same work? If the temperature yesterday was low and today's temperature is very high, will you be able to do the same work as you did yesterday?
No, sir. No, sir.
No, correct? Why?
Yeah,
Because some amount of energy is lost
it's
because of
lost
this
from our
work.
body.
An ideal machine, that is what? In ideal machine can assume there is no loss. If you are an ideal person, there will be, you will be able to do same amount of work irrespective of the change in weather. Correct? No? But in a
Yes, sir.
real machine, there is a loss of energy. Now, what is this loss? This loss is basically due to friction. It has to, there are machine has got lot of parts and both are, all are making contact with each other. It will rise friction. Correct? No? Most of the energy loss happens. So that is what is the real machine. In real machine, there is a loss of energy that is called friction. Is it clear?
Yes, sir.
Yes, sir.
Okay, unfortunately, we are coming to an end. I could not complete what I planned for it. So anyway, let's not worry much because I should have done at least one numerical, but I could not do before I can complete certain parts. Okay. Okay. So let me put you on the board. What is ideal machine? So an ideal machines is the machines which have no loss in energy in any manner of the machine, or the machine which have 100% efficiency. What is efficiency? Efficiency is work output by work input. Correct? No? Right? So it says 100% efficiency. That means work out equals to work in. Right? But actual machine, as you've just now taken the example of Kirti, there are some laws, and because of that, an actual machine doesn't have always less than 100%. In actual machine, so this is the real machine, ideal machine. In actual machine, W out would be less than W in. Is it clear? Yes?
Yes, sir.
Good.
Yes, sir.
So you have we have to stop now because you have a class, right, after 11:30?
Yes, we have.
Okay. So we'll continue on this. So what I'll do is, okay, you have classes, right? We could not complete much. I'll share you some, no, my assignment end of the day today, but I could not do a numerical on this. But whatever we have done, some questions you should be able to answer. So all of you, please take your
Yes, sir.
mailbox, and tomorrow we'll gather. And tomorrow, please try to be in time so that we can cover as much as possible.
Yes, sir. Okay, sir. We'll be on time.
Okay,
Yes,
then
sir.
see you. And any doubt you have, suppose someone has some doubt and you could not understand what I spoke today, or you have forgotten, please do not hesitate to ask me. Okay, fine.
Yes, sir.
Okay then. See you all tomorrow. Bye bye.